Hi everybody, today we're looking at inverse functions. So let's start by thinking about what a function is first of all, and we've talked about this before, but one way to think of a function is it takes values from the domain and then from them creates values that sit in our range. And so then in the diagram below we've got x representing values in the domain and y representing values in the range, and f of x, the function, is kind of the operator that takes values from the domain into the range. Now, if I've got a function, then I want to find the inverse function. So if the function takes values from x and creates values, or takes a value from x to y, then if I could find an inverse function, what it should do is it should take the value of y and from that give me x when I apply it. So an inverse function should just work back the other way. So it takes y and then acts on it to give me x, and that would give me f inverse, or my inverse function, the opposite of the operation of f. Now this opposite function, or this function that acts on y to give me x, we call the inverse function, and it's f inverse of x, and we just call it f inverse. Now the formal definition is that if I compose that with my original function f, it should just give me x. Because if I think about it, if I take x, a value in my domain, and f acts on it, then I get y. Then after I've had f acting on it, I then apply f inverse to that value, which is y, and it will just take me back to x. And so f inverse composed with f will just give me x, provided that it's the correct inverse function, because it just goes in a circle. X, when I apply f to x, it takes me to y, then when I apply f inverse to y, it takes me back to x. Now, how are we going to find the inverse function? Well, first of all, let's note that although we're using a power of -1, that doesn't mean that the inverse function is 1 on f of x. Okay, so the power of -1 is saying that it's the inverse, but it's not technically, it's not, I suppose, we don't use it in the mathematical sense of it being 1 on f of x. So if we look at the diagram that we had above, now x is representing the values, or x is representing the domain of f, and y is representing the range of f. But then for my inverse function here, and I might do it in a different color, in green, this is f inverse, and for that y is representing the domain of f inverse, and our x is representing the range of f inverse. So the x and the y for f inverse have swapped roles to what they were before for f. And so to be able to find the inverse function, what we do is we take the relationship for f and we swap the x and the y. And then we rearrange it to give it in terms of y equals. So let's see how that works. I've got f of x is equal to x squared plus 3 for x greater than or equal to 0. So let's first of all write it in terms of y equals x squared plus 3. Now I swap the x and the y, so x is equal to y squared plus 3, and then I rearrange for y. So I'm going to get x take 3 is equal to y squared, and so y is equal to plus or minus the square root of x plus 3. y equal to plus or minus the square root of x plus 3 is not actually a function. It's two separate functions. If you think about it, y equals positive x root x plus 3 is that one, and negative root x plus 3 is this one. So then the inverse function has to be a function, so we've got to ask ourselves, okay, which one is it? Now if I go back here, remember we said that the domain of f is now the range of f inverse, and the range of f is the domain of f inverse. Now the domain of f was x greater than or equal to 0, which is the range of f inverse. So the range of f inverse is y greater than 0. And so I only want the positive values. And so the inverse function is root x plus 3. And that's a function on x. So it's f inverse of x is equal to the square root of x plus 3. So I've got to finalize it by writing it in terms of function notation. Okay, alright. Okay, so now if we go to our second example, finding the inverse of this function. So again, we start at the same place. So we start by saying that y is equal to 1 on x take 2 plus 3. This is a relationship for f. And then to find the f inverse, so the inverse function is the same relationship with the x and y swapped, so it's x is equal to 1 on y take 2 plus 3, and then we want to rearrange for y, so I'm going to take 3 first, it's 1 on y take 2, and then bring that up, so y take 2 times x take 3 is equal to 1, bring the x take 3 down, so y take 2 is 1 on x take 3, and then so y is equal to 1 on x take 3 plus 2. Now, it does ask us to graphically determine whether the inverse is also a function. We'll get to that in a second, because it also asks us for the domain and range of the function and its inverse. So again, for the domain of the original function, so let's go domain of f, so I'll just put a d with a subscript f. Well, any real value can be put in for x apart from 2, because if I put 2 in, then I'm going to get 1 on 0. But apart from that, I can put any number in, and it's going to give me a number out. So x is in the reals. Now the range of f, well, the range of f is a little bit harder. But if you think about it, as x goes to positive or negative infinity, 1 on x is going to go to 0, and so the graph is going to approach 3. So if I draw the graph here, and so like that, then at 2 is a vertical asymptote, and at 3 I've got a horizontal asymptote, so the graph would look something like that there, and something like that there. And so then that would, so my range in this case would be every number apart from 3. Now I should have said x not equal to 2 there, and here y not equal to 3. Now remember when we were talking about the inverse function, we said that the range of f is the domain of the inverse, and the domain of f is the range of the inverse. So, in that case, if I'm writing down the domain of f inverse, then it's going to be x in the reals, x not equal to 3. It's just the range of f. And then the range of f inverse is y in the reals, y not equal to 2. So the domain and the range just swap. And notice that makes sense, because if I think about when x equals 3, then I get 1 on 0, so that can't be in the domain. And then as x goes to infinity, y will just go towards 2, so that's not going to be in the range. So, in this case, well, no, in all cases, the domain of f inverse is the range of f, and the range of f inverse is the domain of f. This relationship always holds. Okay, we'll leave it there. There's some more exploration we will do in class, but for the moment, that's the key concept. Swap the x and y and rearrange to get it in the form y equals. And as I remember, just one more step in this case to write it as f inverse of x is 1 on x take 3 plus 2.